Let's go over operations with radicals today. And we're going to go through these lessons quickly since we're going to combine them all into one kind of super lesson. All right, so radicals. What are radicals, first of all? Radicals are those symbols that you've seen before that looks like a check mark and a long division sign. Okay, this one is the square root symbol. And it basically means what number times itself is the number underneath the symbol. So for example, if we took the square root of 25, we just ask ourselves, what number times itself is 25? Well, that would be 5 times 5. And so the square root of 25 is 5. 5. Okay. This is the number underneath is called the radicand. The symbol is called the radical. And then sometimes you'll see another number on top of it. It could be 3, it could be 5, it could be 8. That is the index. It tells you which root you're taking of a number. So if I was looking for the third root of 8, well, this is asking me what number times itself 3 different times is 8. And well, that happens to be 2 times 2 times 2. And so the third root of 8 is equal to 2. Okay, so if we don't see a number there, we assume that it's a 2, and it's called the square root, okay? And it's just what number times itself. So 2 of them. It takes 2 of them to make the number. Okay, so that is a radical expression. That is the basics version, okay? The number underneath is called the radicand. The symbol is a radical. And then the index tells you which root you're taking. And most of the time we're going to be talking about square roots if we don't see anything there. But sometimes you might see a 3 or a 4 or a 5. And those get a little trickier, but basically the same concept. So let's go down. One of the ways that you see this is in the Pythagorean Theorem. If you remember the Pythagorean Theorem, it deals with right triangles. That's a triangle with a 90-degree angle inside of it. And the Pythagorean Theorem says that you can find the lengths of the different sides because all of the sides are related. If you add the squares of the both legs, they will equal the square of the hypotenuse, the side that is the opposite of the right angle. So for this triangle, a squared plus b squared equals c squared. It's a very famous theorem. And then once you've done that and you want to find, let's say, for example, this is 3 and this is 7. Well, 3 squared plus 7 squared, that would be 9 plus 49, which would be 58. Okay. Well, c squared will equal 58. Well, that doesn't help us because we just want to know what c is. And so to undo a square, you take the square root. And so what is the square root of 58? Well, there's no perfect square. There's no number times itself that equals, no integer number at least, that equals 58. So we would just have to leave it as the square root of 58 for right now. C would equal the square root of 58 for this triangle. So this side would be 3, let's say inches. This side would be 7, let's say inches. And the hypotenuse would have to be the square root of 58 inches in order to match our Pythagorean theorem. So it is useful in finding the opposites of squares, basically, or the opposites of exponents. If it doesn't have a perfect square, okay, if it is not the same number times itself, like we just said 58, there's no number times itself that equals 58, that's an imperfect integer, we're going to call those irrational numbers. So the square root of 2, we don't know a number off the top of our head that multiplies times itself to equal 2. It's a decimal. a number with a decimal, so we're going to call this an irrational number. If we do know the answer, let's say the square root of 4, we know what the square root of 4 is because we know what number times itself equals 4. That's 2. So that is a rational number. If you can write it as a fraction, it's a rational number. As a terminating, it ends decimal, rational. Repeating decimals, those are rational. But if it's a decimal that never stops, it keeps going on forever, that's going to be irrational. And that's what happens when we try to find the square root of non-perfect squares. So let's go down. Let's look at this. All right. Sometimes we need to be able to simplify square roots, basically break them down, reduce them. And to do that, what we do is we break up the number into its factors and see if are any of those perfect squares that we can understand and actually know. Like, for example, the square root of 18. Well, there is no number that times itself that is 18. So let's see if we can simplify this a little bit. How do we get 18? Well, let's look at the factor tree of 18. Let's break it down. 18, that's 2 times 9. Okay, 2 is a prime number, so we can't go any lower than that. But 9 is not. That's a composite number. We can break that down to 3 times 3. Both of those are prime numbers, so we've broken down 18 as far as it's going to go. The square root of 18 is going to be the same thing as the square root of 2 times 3 times 3. Well, remember what a square root symbol means. It means what number times itself 2 times is a number. Well, we don't have 2 2's, but we do have 2 3's. And so we know what the square root of 3 times 3 is. It's 3. And so we pull that out of the symbol because it's no longer, we know the answer. The square root of 3 times 3 is 3. But we don't know the square root of 2, so we have to leave that inside. 3 square roots of 2 would be the final answer. That's the reduced, simplified version of 18. Now this gets easier the more you practice, so let's keep doing a couple more. All right, let's try B. 5 square roots of 48. Well, let's break down 48. What do I know that multiplies together to get 48? Well, 6 times 8, that's 48. All right, 6 breaks down to 2 times 3. Those are both prime numbers. They can't be broken down anymore. 8 is 2 times 4. Okay, 2 is prime. Let's just circle a prime number so we know that we're stopping at those. 4 is 2 times 2. Now we're through. We don't have anything else that's being multiplied times itself to get any of these numbers. If you broke down 2, it'd just be 2 times 1. It'd just be a loop. You can't keep breaking it down. So that where these are prime numbers, these are the ending points for when we factor. So let's see. So now instead of 5 square roots of 48, we're going to write 5 square roots of, let's see, 2 times 2 times 2 times 2, because there are 4 2's after I broke 48 down. 1, 2, 3, 4, and a 3. Okay, that all equals 48. 2 times 2 is 4, times 2 is 8, times 2 is 16, and 16 times 3 is 48. So 5 square roots of 2 times 2 times 2 times 2 times 3. And remember, it's a square root, which means we're asking ourselves what number times itself. Well, here's a pair. Here's a number times itself. Here's another pair. Here's another number times itself. So they will escape the square root symbol, and it's just going to be 5. We already had that on the outside. Now we have a 2, and now we have another 2. And then we still have the square root of 3, which we do not know. It cannot be broken down anymore. And so 5 times 2 is 10. 10 times 2 is 20. So 20 square roots of 3 is the simplified version of 5 square roots of 48. basically break the numbers down into their factors. If it's a square root, you need 2 of them to pull it out. If it was a cubed root, you would need 3 of them. You pull out what you can and leave inside the things that you cannot pull out. Combine on the outside, of course. Let's look at E. We'll do E. The square root of 45b cubed. Well, 45b cubed, let's break both of those down. 45 is 9 times 5. 5 doesn't break down, but 9 does. 9 is 3 times 3. And so the square root of 45 would be 3 times 3 times 5. Okay, let's break down b cubed. B cubed would be b times b squared. And b squared is b times b. So 3 times 3 times 5 times b times b times b. Let's simplify that. We know that we need 2 in order to take the square root of something. So the square root of 3 times 3, well, that's 3. The square root of b times b, oh, I hate this dictionary thing, is b. And we still have a 5 and a b left underneath, and so 3b square roots of 5b would be our simplified version. Just separate this part. 3b square roots of 5b. So that's basically how to simplify square roots and what square roots are. Okay, let's just look at one little cubed root right here just to make sure you can do these. The cubed root of 24, well, let's break down 24. 24 would be like 2 times 12. And 12 is 3 times 4. And 4 is 2 times 2. So the cubed root of 24 is going to be the cubed root of 2 times 2 times 2 times 3. Remember, it's a cubed root, so now we need 3 of them. What number times itself 3 different times is that number? Well, 2 times 2 times 2, that's 3 of them, so that one will come outside of the sign, because the cube root of 2 times 2 times 2, or the cube root of 8 is 2. And you're still left with the cube root of 3 inside. So 2 cube roots of 3 would be this one. So that's the basics of how to simplify roots. Okay, factor the number, and you can use the factor tree, or you could look for perfect squares, but you need to be able to factor. And then as you break it down, you look for what is needed to get out of the root. If it's a square root, you need 2. If it's a cube root, you need 3. Okay, real quick, let's look at this down here. Remember, roots are basically just fractional exponents. Okay, the numerator tells you the degree on the variable, that what exponent you're taking it to, or the term, and the root is the denominator. It tells you which index you're going to. So for example, like 13 to the 1/4. Well, that means there's 13 to the first power, which is 13, and the root that I'm taking is the 4th root. So the 4th root of 13 is 13 and 1/4. 7 and 3/5. Well, we're taking 7 to the 3rd power, the numerator, and the root that we're taking is the 5th one. So 7 to the 3rd power, the 5th root of 7 to the 3rd power. X to the 2/3, well, that would be x squared, and we're taking the cubed root. Okay, so fractional exponents are the radical system, the root system. Sometimes you want to write it one way, sometimes you want to write it the other way, but they can go back and forth. All right, let's go to the next lesson real quick. All right, adding and subtracting radical expressions. Well, it turns out that it's very much like adding and subtracting all of our other expressions. You can only combine like terms. So if we're looking right here, 2 square roots of 7 plus 3 square roots of 7 plus 2/3. Well, what are my like terms? The ones with square roots of 7. So that's 2 square roots of 7 plus 3 square roots of 7. Oh, that's fine. So that's 5 square roots of 7. But we cannot combine unlike terms. And so the 2/3 is still sitting off to the side. So 5 square roots of 7 plus 2/3. That's not a 4. That was supposed to be a plus sign. It gets a little tricky doing this with a mouse. The laptop. Okay, let's see. Combine like terms. We have square roots of 6 and we have square roots of 5. So let's combine like terms. 5 square roots of 6 minus a square root of 6 is 4 square roots of 6. 2 square roots of 5 plus 7 square roots of 5 is 9 square roots of 5. And there we go. Okay, combining like terms. Sometimes, though, you're going to need to simplify before you can combine. Let's look at C. You have 2 plus 2 square roots of 2 plus the square root of 8 plus 3 square roots of 2. Well, 2 is going to stay the same. There it is. It's an unlike term. But I do have square roots of 2 and the square root of 8. So let's look at 8 real quick and see if we can simplify that. That's 2 times 4. And 4 is 2 times 2. So the square root of 8 is the same thing as 2 times 2 times 2. All right, well, the square root means I need 2 of them. What number times itself? So that's 2 square roots of 2. So now we can combine it with our other like terms. 2 square roots of 2 plus 2 square roots of 2 is 4 square roots of 2. 4 square roots of 2 plus 3 square roots of 2 is 7 square roots of 2. So 2 plus 7 square roots of 2 would be that answer. So remember, combining like terms like we've done before, x's with x's, y's with y's, square roots of the same radicand with the same radicand, square roots of the same radicand. All right, let's just look at real 7 square roots of 6 plus 9 square roots of 6 is 16 square roots of 6. See? Sometimes we might have to break these things down, but they will simplify to be the same thing. Let's look at 6, 3 square roots of 9. I know what the square root of 9 is. That's 3. 3 times 3 is 9. So that would be really 3 times 3, which is 9, and 5 times 3, which is 15, and 9 plus 15 is 24. So sometimes you can simplify first. The square root of 9 is a rational number. It is 3. Just remember, on perimeter, you're adding up all of the sides, so you would add up the same terms, like terms. So the perimeter of this rectangle, well, that would be 3 square roots of 2 and 3 square roots of 2 and 7 square roots of 2 and 7 square roots of 2. That's 14 square roots of 2 plus 6 square roots of 2, which is 20 square roots of 2. Perimeter of this kite, well, you would add up all these things, but I would need to simplify the square roots of 8. Remember, that turned out to be the 2 square roots of 2 when we just did it a minute ago. So there'd be 2 square roots of 2 and 2 square roots of 2 and 6 square roots of 2 and 6 square roots of 2. So that's 12 square roots of 2 plus 4 square roots of 2. That's 16 square roots of 2. It does get a little bit of a mouthful saying all this, but basically add and subtract like terms. Make sure that you simplify them, though, first to see if sometimes you might have like terms in there and they don't look like it at first. All right, and let's look real quick at multiplying and dividing. Okay. Ooh, I already wrote something there. Let's see. Multiplying radicals, you need to just multiply the coefficients, the numbers on the outside, and multiply the radicands, the numbers on the inside. So 2 square roots of 4 times the square root of 9 is going to be 2 square roots of 4 times 9, which is square root of 36. 2 square roots of 36. And then I would probably need to make sure that 36 can simplify, because I know what the square root of 36 is. That's 6. 6 times 6 is 36. So it's really 2 times 6, which is 12. Okay, so basically that's all there is to multiplying radicands. You multiply the outside numbers, you multiply the inside numbers, and then you simplify, just like we did in the first lesson. So let's look at this one. 2 square roots of 10 times 5 square roots of 3. Well, that's 10 square roots of 30. Can we simplify 30? Well, let's see. 30 is 2 times 15. 15 is 3 times 5. I do not have 2 of anything in there, so there's nothing that's going to be able to be taken out. So the square root of 30 is the simplest form of it. I don't have 2 2s, I don't have 2 3s, I don't have 2 5s. So 10 square root of 30 is the answer, and simplified answer for this one. All right, let's look at dividing. The thing about dividing is that, again, we want the numbers to be under the same kind of root. Okay, so don't mix cube roots and square roots, just like on multiplying, we didn't want to mix cube roots and square roots, or adding and subtracting, we couldn't mix cube roots and square roots because those weren't like terms. But everything else is really sort of just dividing normally. 4/5, and then you have the square root of 42 divided by the square root of 6. Well, what's 42 divided by 6? 7, so that's 4/5 square root of 7. All right, 10 halves next to the square root of 54 divided by 2. Well, 10 divided by 2 is 5. 54 divided by 2 is 27. So that's 5 square roots of 27. All right, and let's check that. 27 is what? 3 times 9. And 9 is 3 times 3. So that's really 5 square roots of 3 times 3 times 3. And I can take 2 of them to get out of there. So it's going to be 5 times 3 square roots of 3, which is 15 square roots of 3. So dividing, you basically want to make sure that the index is the same and then divide normally. Okay, like 16 over 8, that's 2. 8 divided by 1 is still 8, so that's going to be the cubed root of 8. X to the 11th power divided by x to the squared. Well, 11 minus 2 is 9, so that's x to the 9th power. And then there's a little trick that you can actually divide your exponents by the index if you want to. 9 divided by 3. Well, that's going to be 3, so it's going to be 2x cubed. And the cube root of 8x to, nope, 8, just 8. And the cube root of 8 is 2, because 2 times 2 times 2. So it's really just 2 times 2, which is 4, 4x cubed. That one might have gone by a little fast. Let's go this again. All right, so we divided first. We said 16 divided by 8 was 2. We said 8 doesn't have anything to divide by. It's just 8 divided by 1, which is 8. X to the 11th divided by x squared is x to the 9th, because when you divide exponents, you subtract. Okay, we got 2 cube roots of 8x to the ninth. All right, now let's simplify. The cube root of 8. Well, what number times itself 3 times equals 8? It is a perfect cube. It's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So the cube root of 8 is 2. Okay, that equals 2. And we already have a 2, so we said 2 times 2 is 4. Now, how did I get this x cubed on the outside? Well, the cube root of x to the ninth. Well, that's 9 x's multiplied times each other. Okay, and I need 3 to get out. Well, I can have, if there's 9 of them, that means there's 3 sets of 3. Okay, that means 3 x's came out, x cubed. All right, and then sometimes you want to be able to rationalize the denominator. That means we don't want square roots or cube roots in the denominator. And so to get rid of them, you just need to multiply the denominator times itself. But also remember that whatever you do to the bottom, you need to do to the top. So you're going to multiply top and bottom by the same denominator. For example, the square root of 11 over the square root of 6. Well, we multiply both by the square root of 6. Because remember, square root of 6 times over the square root of 6 is 1. And multiplying by 1 doesn't actually change the number. It's just making it into an equivalent form. The square root of 11 times the square root of 6 is the square root of 66. The square root of 6 times the square root of 6, well, that's now 30, square root of 36, but we know the square root of 36 is just 6. So that'll be the square root of 66 over 6. Or another way to write that would be 1/6 times the square root of 66. Can I simplify the square root of 66? Well, that's 6 times 11. 11 doesn't break down. 6 is 2 times 3. There's not 2 of any number to bring out, so no, I cannot simplify the square root of 66. So basically, when you rationalize the denominator, multiply it times itself. That one will become it will get rid of the square root sign basically and have just the number, and then multiply the numerator by the same amount to keep it even.